Okay. Hello, everyone. Today I would probably skip trading part because it's just distracting me, and I'm going to describe the concept about emotions and mechanics of emotions. So it's supposed to be quite interesting. Give me a second, just open my drawing tools, and we go. Right, where is it? Yeah. So it's important to understand the mechanics of emotions while you are trading, simply because once you understand what happens with your mind and body, then you do less mistakes, I suppose. So, okay, let me get from here and open it here, one drawing. And you see that already, right? So, well, first is we have to understand there are different ways of interacting with reality, and there is a hierarchy of ways of doing so. And the lowest point in that hierarchy is pain or immediate sensitivity, so to speak. So we've got our senses, skin, in the ears, noses, tongues, and so on and so forth. So, five senses. And the mechanism is that they are accepting particular stimuli, and that stimuli are generating the reaction in the body, and that reaction is overwhelming, and hence we have to do something in order to change ourselves or the environment, right? So let's say you touch a hot stove with a finger. So you see that. So what happens basically? The impulse is going through the nerves here somewhere in the spine, and the immediate reaction is generated, and we just take the hand off the stove and like save our fingers. They are not burned. We just get a bit of burn bones. We don't burn completely to the bone because we feel the pain and we react. We feel pain, and later, when the impulse about this event is getting into the brain, and then we start thinking about how we got there, and it's really painful, and so on and so forth. So somebody in our skin and mind is feeling the actual pain, but the body is reacting much faster than we actually could put it in a thought in the head. And this is like, as you can see here, it's immediate, and the speed is below 100 milliseconds. Uh, I don't want to go too deep in there, like the type of neural paths and so on and so forth, but they're fast, and they're fast because they're supposed to be effective. What important here, important part here is that uh, there are uh, there are evidences that pain could be felt, so to speak, felt. We never know because we can't really be hydroid in order to know does it feel or not, or jellyfish, whatever. But like the concept of pain, we could see in really primitive, or I can't say primitive because it's wrong to say primitive, because if jellyfish is here now, is not primitive because it managed to survive. But like, let's say simply organized, no, simply organized creatures, right? They have pain, and what that means is the mechanism of pain itself appeared really long time ago, or I believe it appeared when the first multi-cell organisms appeared, and some of them had taken this function to be neurons and provide particular signals between cells, and then make sure that cells are able to react for stimuli from the environment. So what that means for us is that like pain is really hard to ignore. So if you've got toothache, right, so you can't really trade the law because you can't really not think about toothache or stomach ache and so on and so forth. However, uh, we have to understand the origin of all that, and we have to understand that like the more ancient the experience is, harder to ignore it, and more automatic it is, right? So that's probably it for that thing. So what I've got here, yeah. So simply, so we are getting stimulus at a hot stove, then we got a reaction, our muscle movement, and then we are getting some expectation, which is like the fingers stop being burned, right? And we stop feeling painful hit our fingers. So that's the pattern. So we always get a stimulus. We've got the reaction, and we've got the result, right? So that's the main thing, and this is working for all levels of our analysis, not just the pain response. So the important part about pain is it's false positive reaction quite frequently. So what that means is when we just experience a bit of pain, we do something immediately, despite this pain wasn't that sort of damaging to our health and so on and so forth. So we wait a bit, hold it a bit, and then it will be alright. But like instead, we react immediately, and this evolution is pushing us to this action, and it does it because it's the following. So let's say we have a, I don't like this slide. Let's say we have a normal distribution of organisms. Right? So here is the delta reaction, and here is the number of, let's say, individuals or whatever. So what we're getting is something like that, where we have majority of us who reacted in a particular way, and those who survived and got genetically determined pain reaction. Those who didn't react during the evolution, they died out because they didn't really react when they feel pain, and they didn't really, how to say, save their bodies, and it's really a disadvantage to ignore the pain reaction in your body. Right? Then there is also some sort of illness when people don't feel pain, and mostly they die in early age because they eat their leaves or they jump from heights and break their legs constantly simply because they're not afraid, they don't feel pain, so they don't get experience, right? And so what that means is, so we've got this normal, let's say, normal reaction among most of us. There's another cohort of individuals on the right hand side who are overreacting to pain, and they also died out because, well, I think because they everything they touched, they felt pain, and then like, got overwhelmed and moved in like wrong directions, and hence didn't get into this golden middle. Right. So, what important to understand here? This normal distribution was happening during multiple generations and multiple species, and so on and so forth, and hence we have this like unified reaction. So, what that means also is that during first several millions, or tens or hundreds millions of years, uh, our ancestors were getting those reactions packed for us in order to get this middle middle was like middle area of this distribution, and we could assume that, let's say, wolves and dogs and cows and so on and so forth, we have similar reactions to similar pain stimuli. When we cut something, or when we like I don't know burn something, and so on and so forth. So this is how we got here, and this is why this quadrillion, quadrillion iterations during the evolution for those millions or billions of years got us where we are, and we've got this genetically defined pain reaction. So that's that. And if we get back to our picture, so what we have here is so you see, like a spine is really ancient thing, right? It's like I don't remember how many millions ago, a lot of millions ago, but like before dinosaurs, before fish, before who else? Before fish, worms. Yeah, worms. I think worms have first the spine-like nervous thing. So nervous stub. I don't know whatever called. Yeah. So what that means is also that this system here, which is reacting straight away on pain and does something, it's like plenty of millions years away. Let me have a look, because I've got a book. Yeah. How long ago spine brain appeared? As Google says, 530 million years ago. Yeah, half a billion. Right. That's a lot, isn't it? So let's write it down. 530 billion years ago. So that's this system is that all 530 billion years ago. Now, the next, okay, that's pain. So that's the emotion of pain. Yeah. Okay. So let's go back to emotions. So emotions are rather similar to pain. The only difference is it involves a bit more complicated brain structures. So let's say we've got emotion. What emotion? We've got fear, or more older one is the seeking emotion, right? Seeking emotion. And again, regarding the emotions themselves, you can read Parksep or go and look previous stream. You see what kind of emotions there are. But let's say seeking emotion, the fear, the next to it. So what happens here? Let's get back to the image. Right. Oh, I leave 530 billion alone, or I'll probably draw here a bit. So regarding our emotional things, right? So what we've got here is we've got eyes, we've got ears. Let's say what else we've got? Eyes, ears, smell, and so on, like taste. So what happens here? We are getting that stimuli in our lower brain region here, right? And because we've got there some memory, there's some hippocampus, which is responsible for spatial navigation and so on and so forth. So like a bit more complex structures than just like immediate muscle reaction to pain. And what happens there when we hear something, see something, expect something, we are getting an emotion. So, for example, in a bush, in jungle, monkey hears something suspicious, starts to fear, and then starts to shouting, dragging attention of the group in order to understand, in order to help it to understand what's going on, making sure they also know that there is a particular unknown danger and stuff like that, right? So what happens here is we stimuli are getting to our senses, but more complicated senses than just touch, and they are combined into particular mix of stimuli in lower parts of the brain. Let me get closer to that. Yeah, yeah. So it gets. Okay. So it sees something, hears something, right? Like smells something. Some memory appears also, and there are embedded genetic images in the head. For example, some claws or some I don't know fangs and so on, like some horror nasty stuff, and then the amygdala goes nuts and starts sending like signals all over the place, and then you start reacting. So what important here is that unlike pain, it's not that fast because it involves more complicated mechanisms, and perhaps it involves more complicated neural connections, so more neurons in the chain, and all of them supposed to get lined up. So it's a bit slower, but still, it's like 100, 500 milliseconds, and almost immediate reaction. Limbic system is reacting, and also it helps to release hormones like adrenaline, for example, or cortisol, and the stress response goes straight away, and then you are getting excited by the emotion and stuff like that. So that's that. Now, so that's the emotion, right? And let's ask when spine brain. Let's ask when how long ago lower brain appeared top of the spine. I think it's also quite old. Okay, so it says like 300 million. 300 million. You got a third of a billion, so that's a lot as well. And we could also assume that like other species do have emotions, not even species, but other kingdoms, like other branches, right, have emotions like birds, like fish, maybe, well, mammals for sure. Mammals display a lot of signs of emotions in them. Now, what important here is that, like, again, it's a fast thing and it's old. So what that means is when you feel something, when you experience particular emotion, fear of missing out, or fear of losses, and so on and so forth, or greed for that sake, that means it's quite old, and that means like it's hard to control that, or at least you have to articulate that you've got the emotion, so you feel it, so you can ignore it. The same as pain, right? So in order to be able to raise your pain level or pain tolerance level. So you have to expose yourself to a lot of pain, and then you get used to it, and then it's not pain for you anymore. And for some, like, sick bastards who like go to Muay Thai classes, they love pain because but that's another story. That's about like neural cortex and stuff like that, right? So that's there. Now, the core concept here. What kind of core concept here? A core concept is that the mechanism. Right, okay. Yeah, pardon. So basically, it doesn't matter is it pain or emotion or even a high, complexity of the behavior. The concept is the same. So we are getting some information from the environment. We are acting, our agent acts, and then there is a result to be expected. So, in terms of pain, right? So we've got like hot stove, right? Action is to move a hand away, and then the result, like hand is not hot anymore. So that's the not hot, right? That's immediate reaction. That's what we've got there. The result itself is supposed to be sort of automatic with emotions as well, more or less. The result is expected because the stimulus is danger, then action is to run away or be alerted, and then the result is less danger, right? Less danger, right? So, what the problem is, and why I mentioned that the age of the reaction is important, uh, and why it's different from neural cortex activity. The difference here is for an emotion, the result is predetermined in our genes, right? So basically, when we get strong emotion, we start doing something, and we are doing because not we expect something is going to change, but our genes do expect it. What I mean by that, that millions of iterations on other our ancestors or other even animals like monkeys and so on, mammals from which we got to this particular stage in space and time, it was working for them. Not for all, but for the majority. For majority of those who survived and gave offspring. And what I mean for us now is similar stimuli call similar action which led to survival in the past. But trick here is it's not necessarily leads to success in the present time, especially in the trading career, especially, and I underline it, because when you experience fear because you see low P&L and market is falling, the the stimulus which is generating the emotion is similar. Like you've seen a snake and you're a little monkey and the snake can eat you. It's the same emotion. Now you start acting, but if it helped for you to recognize the threat and run away, here it would do more harm than good. Because maybe you shouldn't be fear, you shouldn't be scared. You should just have a look. Oh, I pay that. Or maybe I'll have to like hedge it a bit or do this and that, and then be irrational here. Right? And this is why all trainers or whatever they're saying you have to be rational, have to have a plan, this and that. And I'm going to talk about that later. Why this is not a magic bullet, but for now once you recognize that emotion is for the past result for your ancestors, not for you, then you start thinking about, right, okay, how can I deal with that? What should I do in order to avoid overreaction to particular emotions and so on and so forth? So, so right, okay. Again, I'm not going too deep into which emotions by which brain regions are excited and so on and so forth is probably not the topic of today. But one more little thing, the the result, okay, the result of the action is to change the environment or change it themselves, right? So basically what happens, like if you fear something, you run away. That means you place the object in a different part of the space time where you don't have to fear, right? Where it's not that dangerous. Or if you fear something, then you fight, right? And then you change the reality. Then agent changes reality, and then destroys the threat. So, but pain is slightly different, right? Because when you've got a pain, then you immediately do something with your own body, let's say, and then you reduce the stimulus. So, so to conclude, uh, why stick to pain? It's not only pain. Yeah, but pain is easier to describe. Like, okay, the conclusion is stimuli, stimuli of the old parts of neural system, neural system are powerful and hard to resist. To resist. So understanding of that is helping you to navigate yourself and to understand that if you experience particular emotion, and it probably helps everywhere at the workplace or relationships or with your kids or whatever. So when you do experience particular emotion, all you have to remember is it's really ancient thing, and that ancient thing is not designed to help you here and now. It just did for your ancestors, and you experience, you got that inheritance, right? And you have to live with it, whether you like it or not. But this is the framework in which all of us are operating, and this is the framework we are uh, we are we are living, right? And the trading itself, again, the conclusion here, the trading itself, it it is the activity which is the opposite to our survival instincts, to our survival mechanisms in our body, and that's why it's really hard to trade. But that's like emotional speech for the next time when we get like separate emotions and try to understand why we feel particular things in particular cases and how to avoid it and what the pitfalls. But for now, the main thing to me to understand is this, right? So you feel pain, you feel emotion, that means 300 million years it helped to survive not only you, but the dinosaur who was before you, and your dinosaur ancestor, unless you are not a believer in the Bible story and saying like, okay, God did create a human like 10,000 years ago, almost forward. Like, if you're stick to science and official evolution theory, that means like we had ancestors like fish and dinosaurs and so on and so forth. So that means even dinosaurs did experience some sort of similar emotions like fear, greed, rage, and so on. And that means like if it helped them, right, and it was like, let's say 300 million years ago, it doesn't necessarily help us here. It would, but not necessarily, not 100%. Right. So that's probably it for pilot emotions. And next time I'm probably gonna get separate emotions and the trading conditions like fear, greed, seeking, and so on and so forth. Thank you very much for your attention.